Hey everyone. One question I really get asked commonly is what is the difference between science in college and science in high school? And I'm just going to tell you right now, science in college is conceptual. What does this mean? It means it relies on your understanding of fundamental concepts and applying them to the world around you. You might think that that's what you learned in high school, but unfortunately, most high school students, their high school usually teaches them something that relies entirely on memory, um, or maybe even formulas. Also, excuse my handwriting. This is the first time I'm using this app, so my penmanship's clearly not very good, but maybe we'll get around that. So, anyway, let's see what this means. I'm going to go ahead and show you what this means with an actual example that is um, from an actual chemistry 1A question. This chemistry 1A is a chemistry class at Berkeley, so if you don't know it, that's fine. But anyway, this is a question that says if you keep diluting HCl, which you may know is a strong acid, it is easy to prepare a solution of HCl that is 1 times 10 to the negative 10th molar. What is the pH of the solution at 25 degrees Celsius? And then you have three answer choices: less than 7, about equal to 7, or greater than 7. So I'm going to go through this and kind of show you how a high schooler would approach this and how college expects you to approach this. So the high school approach would kind of have you saying, okay, well, I know HCl. Remember to write the state is aqueous because it's dissolved in water. Is going to break completely down into H plus, also aqueous, and then Cl minus, also aqueous. And it's a strong acid, so we usually assume this will go to completion. More importantly, we started with 10 to the negative 10th molar HCl, right? And as you may know, molarity is a measure of concentration. So technically, this should break down into 10 to the negative 10th molar H plus, and then you should also have 10 to the negative 10th molar Cl minus. Technically, if it breaks down completely. And you'd be right to assume that. Now, remember the question's asking for pH. So a high school student would now say, all right, well, I remember pH is equal to negative log of the H plus concentration, right? And you'd be right. That's exactly right. And now, maybe if you plug it into the formula, you would now get pH is equal to negative log of 10 to the negative 10. And if you went ahead and plugged this into your calculator, you'd get that pH is equal to 10. And now you'd go ahead and say, pH is equal to 10, and therefore the answer is C. Because remember, there were three choices, and the last one says the pH is greater than 7. So you'd say the answer is C. The problem here is that's actually incorrect. Because what is HCl? HCl is an acid. Remember? And as you may know, at 25 degrees Celsius, excuse me, at 25 degrees Celsius, acids usually have a pH less than 7. And remember, bases usually have a pH greater than 7. If you were thinking conceptually, this answer makes no sense at all. This answer makes no sense at all. Because how can an acid have a pH of 10? Conceptually, that makes no sense. Because conceptually, we usually are associating acids with a pH of less than 7 and bases with a pH greater than 7. So there's absolutely no reason why HCl, something that's very, very acidic, should have a pH that's 10. So there's something we're overlooking. What are we overlooking? Well, let's go to the college approach, which is all conceptual. HCl is aqueous, right? What does aqueous mean? Aqueous means what just happened? I'm gonna see if I can go up. Sorry. Aqueous means in water, right? It's in water. And I don't know if you guys ever remember, but water has a pH of 7, right? And that means water already has an H plus of 10 to the negative 7th molar. That's excluding the HCl. The HCl doesn't even have to be dissolved in it. But now what we're saying is we had dissolved 10 to the negative 10th HCl into water. And when you do that, what you're essentially doing is you have two different things happening here. Because already you have water breaking down. Technically it's not breaking down, so I'm not going to draw the single arrow. I'm going to just go ahead, and if you're not comfortable with these arrows, that's fine. I'm going to go ahead and draw these equilibrium arrows because water is in a equilibrium. And what's actually happening is water is breaking down to H plus and OH minus. And water breaks down such that there's 10 to the negative 7th molar H plus and 10 to the negative 7th molar OH minus. And that's why water has a pH of 7. And now when you add the HCl, for simplicity's sake, HCl, remember HCl now is 10 to the negative 10th molar. And when this happens, we're going to have an H plus Cl minus. And now, this H plus will be 10 to the negative 10th molar. And Cl minus will be 10 to the negative 10th molar. So if you actually wanted the overall pH, like the overall H plus, right? If you wanted the, I'm going to go ahead and go down now. That might be better. The overall H plus is equal to the H plus from water plus the H plus from HCl. And I'm not going to say exactly equal to because there's actually a little bit of funkiness that might happen, but I'm going to say about equal to, right? And if that's the case, then the overall H plus is equal to 10 to the negative 10 molar. Oh, wait. 10 to the negative 7th, right? Because water is 10 to the negative 7th. Plus 10 to the negative 10th molar. And, believe it or not, when you actually add that up, the overall H plus is about 10 to the negative 7th. Because if you add 1 to like 1,000, it's 1,001, which is still just the same as about 1,000. In this case, if you add negative 10 to 10 to the negative 7th, this is 1,000 times bigger than 10 to the negative 10th. And so it's basically about the same. And because it's the overall H plus is 10 to the negative 7th, if you take the pH of the solution, then it would be negative log of 10 to the negative 7th. And you'd see that this is actually 7. And so the answer to the question was actually B. If we go back to that original question we started with, remember all the way up here, the answer is actually B. And so that just goes to show you, conceptually thinking, when you think about conceptually, the answer here is B because this is clearly HCl in water. And not everyone remembers that. And if you remember it, then this high school approach would make no sense. And then you realize acids can't have pHs less than 7. I mean, acids can't have pHs greater than 7, so this answer makes no sense. And therefore, you would come to that reasoning that you're missing something. And what you were missing was the autoionization of water. And when you take that into consideration, you actually get the correct answer, which is about 7. So I hope that makes more sense and kind of shows you just how different it is to apply something conceptually and to think of it with memorization techniques.